So, what have we learnt in this lesson? We've seen that a lot of science does not reproduce. Probably at least 50% in some fields like psychology, medical research. I think that fraction is much less in physics and astronomy, but it's certainly not zero in those fields, and we don't check enough. This is sometimes because of deliberate fraud, but more commonly it's because of various unconscious biases and basically researchers fooling themselves. Even when research can be reproduced, quite often it's useless because it's a dead field or because it doesn't generalize. I don't think any of these are major problems in physics and astronomy, but there are certainly problems in many other areas of science. In physics and astronomy, we still have a very strong culture passed down from supervisors to students of rigor and being careful. But I do worry that culture is weakening and that we could become victims to the same situation. And there certainly are problems in physics and astronomy. There are certainly zombie areas, and there have been cases of fraud, and there are definitely mistakes out there. So why is science become so bad? Having said, this sounds pretty bleak for science. I don't think science is anything like as bad as, for example, politics or journalism or any other fields. But every field is done by humans has these sorts of issues, and I think science is better than most. But I think a lot of it comes down to incentives. What are the incentives for a scientist? And we've seen as the scientific community grow dramatically, you've got very much a publish or perish, where you have to publish lots of papers. So there's time pressure, you have to get them out quickly, which militates against being careful. They have to be in prestigious journals, which means you want exciting results, which again militates against being careful. You're more likely to get an exciting result if you do a sloppy experiment. You need a high profile with lots of citations and exciting results to get funding. So partially this is a bias. If people know that they want to get a job in this field, they love science, they want to get a permanent job, and therefore they're going to be pushed this way. Also, let's say there's two groups of people. One are very slow and careful and methodical, and one are flashy and careless and play fast and loose. Which group are going to get the funding? Which are going to look good to the government? It could be all those careful, slow, methodical people don't get promoted, don't get employed, and left behind. So that's the incentives for individuals. There's also incentive for the universities. Universities and research institutes are also judged on how many exciting publications they put out, how many press releases, how many patents, whatever it might be. They lose funding otherwise. Certainly the Australian National University regularly has to go to government and say, you should keep funding us because of all those brilliant things we do. We are high impact, la-di-da, la-di-da. So the universities reward these things. They have to. A university that doesn't get exciting results and lots of high impact science is a university that will lose its funding. So the incentives all the way up and down the system are to not look too closely at this, to hush things up. Of course it can disastrously backfire. If you're too sloppy and you get a high profile case of misconduct or something, it can do a lot of reputational damage, so they don't want that. But maybe there's an incentive not to be too careful about these things. There's a famous law, Goodhart's law, named after a British economist from the 1970s, that when a measure becomes a target, it ceases to be a good measure. So once upon a time, scientists would judge other scientists by talking to them and deciding whether their ideas were good. But as the number of scientists became so large, particularly governments who didn't understand enough science to have this conversation, start using measures, publications, citations, journal impact factors, H-index, whatever it might be. And as soon as this happens, when a measure becomes the target, it ceases to be a good measure. As soon as people are being measured on how many grants they got, how many papers they published, then it ceases to be a good measure. People will game the system to produce more papers, more citations, get more grants, whatever it's going to be. So we've built a system where there are huge incentives for bad behavior. I actually think it's remarkable there's so little bad behavior. Given all the incentives are to do things badly, it's pretty good that scientists behave as well as they do. I think it's resisted by, a very strong culture. But as science grows so fast, particularly in countries which don't have the long tradition of science, there is a danger that culture gets watered down. That's clearly what's happened in some areas of psychology. Not all areas of psychology. Social psychology very badly affected. Cognitive psychology not so much. But you've got a bad culture where people's levels of rigor drop, and that gets passed on to their students, and they get more results, and so it's exciting, and their heroes will be the people who've been a little less careful, and so the whole standards can slip. So I worry that this sort of thing can happen in physics and astronomy as well, and arguably it already is in some countries. But certainly we need to watch out for this and try and maintain the culture very strongly. Of course, you could argue that we need to police this. If universities are not going to be very rigorous about rooting out bad behaviour because it's not in the university's interest to do so, a lot of countries now have national review boards which have to investigate claims of scientific misconduct because they don't trust the research institutes to do it. Maybe you need to give incentives for replication tests. At the moment, if I'm a researcher and I spend my time testing other people's research, first of all, I piss off the people whose research I tested, who might be important and powerful people, because I'm clearly showing my lack of trust in them by going back and redoing their research. And also, if all I'm publishing is papers saying, yeah, what so-and-so said was correct, I'm not going to go very far in my career. That's not very exciting. So do we need incentives? Maybe we have special institutes whose entire job is to replicate other people's research. Maybe we need a culture that's more distrustful. Scientific culture is, I think, generally very trusting. People generally trust that other researchers have done the right thing, and maybe we need to be a bit more suspicious. But that's going to make collaboration really hard. More like the legal system where everyone assumes everyone else is lying to them, and that's not exactly a model of efficiency. Maybe we need funding based on real impacts, not on how many lives did you save? How much did this increase the economy? The trouble is these are really hard to measure and very long term. The real impact of my research might not show up for decades. How possibly should I get funded now because of that? And it would be very easy to slow science down to a halt. If everything you have to do has to be reviewed and checked 3 times by special committees, then that's going to grind science to a stop, and science is saving lives. I mean, probably the most regulated form of science is medical trials for drugs, and that takes billions of dollars and decades, which means that many really important drugs that could be saving lives take so long to come out that thousands of people can die while you're waiting. And of course, this whole thing can be weaponized. Your rivals can use accusations of scientific misconduct to put down competitors, and people who disagree with science can use it to try and discredit the whole thing. So arguably there's a debate in science, should we even talk about this? I've clearly been talking about it, there's a whole lesson about it. I think it's very important. If we don't talk about these problems, I think they only get worse. When we do talk about them, then enemies of science, like climate change deniers and vaccine skeptics, can say, look, science has a reproducibility crisis, we shouldn't believe anything a scientist says, buy my special medicine. So it's a tricky one. I don't know what the answer is. There's definitely a problem. I don't think it's that bad, at least in physics yet, but it's certainly bad in some areas, and it could easily get worse in physics. I think we have to be aware about it and talk about it, but it's certainly the cure could be worse than the problem.